Now that it's dark and all the kids have gone off to bed, we can talk about the stuff they didn't tell you at school. Now you've all seen this one. Piece of superconductor, it's sitting in a piece of foam insulation. We pour liquid nitrogen on it to take it below its critical temperature. What we have here is a circular track consisting of a whole bunch of magnets. We place the superconductor over the magnets and give it a push. Now, some of you may even have heard the explanation for this. It's called the Meissner effect. A superconductor in the presence of a magnetic field will acquire little surface circulating currents. And these will be oriented so that they generate a magnetic field that exactly cancels the applied magnetic field. So therefore that field is, that little magnetic field is always in the opposite polarity to the applied field, so there's always a repulsion. That's what you've been told, but that's only half the story. Now, the reason why that's only half the story is because this particular kind of superconductor is what we call a type 2 superconductor. Now, all those high temperature superconductors, they're all type 2 superconductors, but they're not the only kind. Many of the old low temperature superconductors are also type 2. But one of the properties of a type 2 superconductor is this. Not only do they exhibit the Meissner effect, but under the right circumstances, you also get partial penetration of the magnetic field through the superconductor in little islands called fluxoids. Sometimes these fluxoids can get trapped on grain boundaries or little blemishes in the superconductor or defects of some kind. And when they get trapped on those, it's called flux pinning. So it's possible to actually trap some magnetic flux lines in the superconductor even though it's exhibiting the Meissner effect. The effect of that is, if you can trap some flux lines, the superconductor will behave, it'll have two behaviours. It'll have that Meissner effect, which gives you a repulsion, but it'll also be as though it has a little bit of a magnet trapped inside it, so you get a little bit of attraction if the magnetic field is pointing in the right direction. So we're going to see if we can exploit that effect now. All right, so now it's below critical temperature, so we're going to see a Meissner effect, but I'm going to see if I can force a little bit of that flux pinning. The way I'm going to do that is I'm going to take this up to the magnet, and rather than just sit it there, I'm going to give it a shove towards the magnet. And when I give that shove, it forces some of those flux lines into little gaps between the crystals and stuff like that, and they stick there. So as I say, now we've got some repulsion because of the Meissner effect and a little bit of attraction because of the pinned flux lines. And so we're going to have these two effects, a repulsion and an attraction. And there's going to be a little sweet spot in the middle where they just balance.